Okay, so we got two-slit interference here, and with two-slit interference you got your two slits here. They're separated by a distance d, and let's see, we have that d is 0.350 millimeters, and the wavelength we're dealing with here is 643 nanometers. And the screen is a distance 5.90 meters away. And we're considering y equals 2.71 centimeters. We don't know what's there, whether there's a maximum or a minimum there, but that's the location we're given. So we need to know what's the path difference for the two slits at this location. Well, these light rays from these two slits go off toward that distant wall, and the path difference, this is the path difference right here between them. Okay, and we know that that path difference, where they go off at an angle theta, this angle also is theta, the path difference is d sine theta. But we know that for this pattern, so if you've got a diffraction pattern over here on the wall, okay, and we're dealing with some position y at some distance L, then that's our angle theta, right? And we know that sine theta is about equal to y over L for very small angles. So I can say that the path difference is just dy over L. Okay? Now that's, see, 0.350 millimeters times y, which is 2.71 centimeters, and then I divide by L, which is 5.90 meters. So I get 1.6 times 10 to the minus 6 meters. That's the path difference. Okay? Now, part B, how many waves is this? Well, number of wavelengths is equal to the path difference divided by the wavelength. Right? This is similar to what we do with thin films. If you want to know how many waves are in a thin film, you take the distance in the thin film and you divide by the wavelength to count the number of waves. Well, in this case, the extra distance is 1.6, and if we want to know how many waves that is, we divide by the wavelength. And when we do that, we get exactly 2.5 waves. Okay, now since we're at 2.5 waves, that must be a minimum. Right? Because any path difference that has some half number of waves, that's a minimum. If the path difference were 0 or 1 or 2 or 3 waves, that would be a maximum. At half a wave, 1.5, 2.5, 3.5, it's a minimum. So in this case, we're at a minimum.